needs to be a bit of cutting afterwards. Now, earlier on, we already tried. Earlier on, you have already tried out the pizza slices. Correct. So previously, you already tried some of these pizza slices. You cut it out, and what you did was to try to put it onto the corners of the triangle. And some works and some doesn't. Too much talking. And then some works and some doesn't work so much. And then some meets and some doesn't meet. Right? Okay. So there are one, two, and three triangles here. And I give you three pizzas. Okay? Now, you do not have to cut this now, but what I will show you is with the pizzas that is cut already. So you can continue to do the activity when you're home. Now, if you remember, there's another piece of paper that we wrote down the dimensions of the angles. Right. So I'm trying to show you with this one I have. I know that Mr. Earl is not here today. So previously we have this copy. And it has the angles written here. And from this pizza first activity, we figure out that when I put the pizza slices together, one of the first property that I learned is the sum of angles add up to 360 degrees. That was the first few properties that I learned. And then we learned also that from here, I can find the next property is the sum of angles on a straight line, 180. Now, the interesting thing is this. I can move these angles, these pizza slices, onto a triangle. So, if you look at the triangles here, you get your pen ready because I want you to write some information on the paper. Most of us were able to identify what is the first triangle that we have. They were able to say that this is the right angle. Now you need a ruler. Anybody else needs a ruler? You don't have a ruler. Come and borrow one. I have long rulers and short rulers. Now, this particular triangle that we formed during our activity just now during maths lesson, the outdoor activity, we were quick to find this triangle. It was a purple triangle. And can you see this one here? That we were quick to be able to identify this as a triangle. And we were able to identify that this angle fits and then this angle also fits. This is how it looks like. And then my next question for everybody for this triangle was that can you find how you use the same three pieces to fit onto the other triangles? Which with some overlap, it happens. You found that right angle here. Can you find the right angle here? Can you find the right angle here? So this is a right angle. And you realize it's just how the paper is rotated. So you can put it in this manner, like an upright manner, and you can see that it looks exactly the same way as this one, but just much smaller. Now, for this right angle here, there's a special name to this triangle. It's called a right angle triangle. I wrote it here. It's called a right angle triangle because in this triangle, in this right angle triangle, there will always be an angle that's right. I've written things on, and I marked out the right angle in all the triangles. Now, these triangles have a special name called right angle triangles because you can find a right angle in them. Now, the next question I want you to do, use your ruler to measure the length of this triangle. The one here, the smallest one here. What is the length of one side of the triangle? Huh? Am I saying 7? 7, right? 7. 7. Okay, so this side is 7 centimeter. What about this side here? Also 7. What about this one here? Oh, sorry. What about this one? Let's measure all sides. 10 cm. Can you do the same for the rest of the triangles as well? Ah, okay. Okay, let's measure this one as well. What is the length of this one? 14 centimeter. What about here? 10 centimeter, about 10 centimeters. And then here, also about 10 centimeter. Now, and then we have the big one here. Do you think they will have the same stimulus? So mine's about 19.3, 19.4. I put 9.4 centimeter. How about the bottom here? Also 19.3, 19.4 centimeter. And then the long side is about 27.5 centimeter. Yeah, 19.4, 19.3. Now, what do you realize about this triangle? There are two sides that are equal. If there are two sides that are equal, I will draw a mark here to symbolize that they are equal. These two sides are equal, and these two sides are equal. When you see a triangle that has two markings like that, there is another special name. Yes, it's called isosceles triangle, and this is how it's spelled. An isosceles triangle happens. An isosceles triangle happens. An isosceles triangle will have two sides that are equal. The interesting thing is this. For isosceles triangle, other than the two sides being equal, you'll realize something about the angles. What is the size of this angle here? The size, exact measurement. It was size A, B, or N. What was A, B, or N? A, B, or N? 45 degrees. What about this angle? This is 90. What about this angle here? 45, that's right. And you realize that this is also 45 degrees. This is also 45 degrees. Here also 45 degrees. Here also 45 degrees. Now, there's this very interesting thing about this particular triangle. For this particular triangle, it is a right angle triangle, and it so happens to be isosceles as well. Isosceles triangle means there will be two sides that are equal and two angles that are equal. Exactly the same number. Now, then my question is a right angle an isosceles triangle? Can you draw a right angle here that is not the same side? So first I must have a right angle. I draw a right angle. Can I draw a right angle using this angle here? And then can I have a triangle that's all sides are not equal? Cannot. You know? Don't know, I try. Is this a triangle? Are two sides equal? Are the sides equal? This is about 4 centimeter. This is about 2 centimeter. And this is about 4.5 centimeter. About that. Okay? Is this a right angle triangle? Yes, it's a right angle triangle. But is it isosceles? No, not isosceles. Can you draw another one? Right angle, but not isosceles. Let me try to draw here. I draw one flat one. Like that. Triangle, like that. I draw like that. Like that. Yes? Different. Oh yeah, my turn it. Okay, right here. That's not isosceles? No. Let's check. About 4 centimeter, 1 centimeter. Oh, it's 4 centimeter. Oh, sorry. It's not exactly 4 centimeter. It's 3.8. Yeah, 3.8. And this is 4.2. So not isosceles. Okay. So in other words, I can have a right angle that is not isosceles triangle. Can I have an isosceles triangle but it's not right angle? Can I? How? Draw one. Okay, just find a space. Let's say I draw 3 cm. Okay, this is 3 cm. And then I draw another one that's 3 cm on the other side. I draw a line. Does this triangle look like a right angle? Go ahead. Is it? Oh, yeah, you're right. I accidentally draw an equilateral. And that's an interesting. Uh, if a Crystal now says this looks like a equilateral triangle, you know what it means? Yeah. Is it right angle? Is it right or right angle? No lah, don't have lah. Right. Okay. Later I see. Yeah. Okay. Okay. So your homework number one, go home. Mark is that line. Can you? Yeah, do it then. I can let you. Okay. Can I understand? Yeah, maybe it's honest. Go home, number one. Cut out one pizza. Take out three angles. Stick it here. Is it okay? Okay now. Okay. Now, next one. This one here. This was the orange, sorry, green color triangle that a lot of people have. This is the orange triangle. The red triangle was very interesting. Does this triangle, this is the second triangle. There's no triangle, right? Check. No triangle. Just now we mentioned a right angle triangle can be isosceles. An isosceles triangle can be right angle. This one, yeah, you realize that this triangle measure all sides. So this is 6 centimeter. This is also 6 centimeter. 6 centimeter. And then you know what? That's not the interesting thing was we asked, right? If I take I realized that I tried all the different pizza slices. There's only one angle that fits. I cannot find any other pizza slices there. And then I realized that why is it equilateral? What angle is this? We will only and always be taking this. For a triangle to be equilateral triangle, I'll bring here. triangle, you realize that there's only one angle that fits here, and it's the 60 degrees one. Okay. There's only one angle that fits here. Is only the 60 degrees. And you realize that all angles of this triangle will be 60 degrees. And why is it called an equilateral triangle? Yes, equi means equal. Lateral means all sides. So an equilateral triangle means all sides are equal. Now, may I have a teacher, please? Yeah. Okay, very quickly before we talk about it. Yeah. Hold on for a while. I'm going to show you something interesting. The last thing that I will show you for today. Okay? Are you getting this? So what I did is, I'm going to take out okay. Now, the last thing that I'm going to show you is this. Skylar, the last thing that I will show you is this. I cut out the triangles. Hello? You cut out the pizza, you don't cut the triangle. I am showing you right now. I cut out two triangles from my paper. And just now in one of the activities, right? I said, for example, this one here. And I said, look, you managed to piece the corners like this, remember? And then I asked you to add up all the sum of the angles in the triangle. And I asked you, use a calculator, press it out, what is it? 180 degrees, right? I said, when is the last time you built 180 degrees? Sum of angles on a straight line. I asked you, can you form a straight line from this? Yeah, then you're like, oh, okay. Then you realize that, hey, you see? Straight line. Right? Can you see the straight line, right? Now look, I put triangles here. Okay? Are you ready? I'm going to show you once. Ready? Yeah? Ready? Can you see it? It's very hard to rewind. You have to go on the rewinding to see it happening. Do you see it? Here's another one. Here's the equilateral triangle. Ready? Okay? All right, that's the last thing I'll show you. Stand back and go already. Bye bye.